In this section, we're going to look at some properties of logs that will help us when we get ready to do 4.4, where we're trying to solve equations. So the first property we want to look at is if we have two things that are multiplied together inside the log, we can split it apart, and we can write it as log of the first thing plus log of the second thing. The base stays the same for those two. If inside we have division, then we write it as log of the top minus log of the bottom. And the last property is that we can, if we have an exponent on the thing inside the log, we can write it out in front. So we can have p times log base b of m. So the thing about these properties is they go the other direction too. If we start with two logs that are added together, we can rewrite it as a single log. We can smash it together as a single log with multiplication. If we start with two things that are subtracted, two separate logs, and they have the same base, we can smash it together and it becomes division. And we could also, if we wanted to, and we will need to sometimes, we have a number in front, we could take it and move it back as an exponent. So again, we're going back this way. So let's practice this. In this situation, it says expand. It means we want to split it apart. We have things that are multiplied inside, so we write log base 4 of the first one. It's multiplication, so multiplication becomes addition when we split it apart, and we get log base 4 of the second one. Here's another one. This really is, it doesn't show the dot there from times, but it really is 100 times x. So we can expand it again. We can split it apart. This is log of 100 plus log of x. And we can actually do something more with this. Remember that if we don't see a base, it's really 10. And also remember that 100 is really 10 squared. And we have that property that says if we have this base and this base that match, it's sort of like canceling it out, and we're left with 2 log of x. So this time, again, we're wanting to expand. So we have division here. So we take log to base 8 of the top, and because of the division, it becomes subtraction. And we have log base 8 of the bottom. It's the same idea here. We have subtraction, or because it's division, we're going to subtract. So we take ln, or the natural log, I'm going to write it capital, of e to the 5th, and it'd be minus ln of 11, the denominator. Now remember that ln has a base of e, and so we have a property here that when the base and the number match, we're just left with the exponent. So we end up with 5 minus ln of 11. This also now wants us to expand. In this case, we have an exponent on the log, so we're going to rewrite it with the exponent out in front. So we get 9 times log of base 6 of 3. And that's our third property. Now here we don't have an exponent, but we can rewrite it with an exponent. Remember, a cube root is really an exponent of 1/3. And once we rewrite it with an exponent, we can take that exponent and put the exponent out in front. So we get 1/3 times ln of x. And here we have an exponent, so we can write that out in front. So we get 2 times log of x plus 4. Now here's something to notice here. When we have things that are added inside the log, we can't split it apart. Logs will not let you split apart addition and subtraction. So we just have to leave it like that. So now we're going to practice putting some things together. So we can see that in here, we really have two things that are being multiplied. This is really log base b of x to the fourth times, and we have a cube root of y. Remember that a cube root can be written as an exponent. So I'm going to write it as a 1/3 exponent there. Now these are multiplications, so I can split it apart, and I can write log of the first thing. Because it's multiplication, it splits apart with addition, plus log of the second thing. Now because we have exponents, we're going to keep going. We have this exponent here, so we're going to take and we're going to write that exponent out in front. So we have 4 times log of x plus, and again this is an exponent, so we're going to move it out in front, 1/3 times log of y. And that's completely expanded now. So here's another one. This is division in the problem, so remember that means we want to subtract. So we have log base 5 of the square root of x minus log of 25. And these two, there's really two things in that denominator. There's really a 25 and a y cubed, but they're both in the bottom. They're both being divided by. I forgot my base of 5 right there. So that means we have to subtract both of them. So this one will be log base 5 of y to the third. So now let's clean up a little bit here. Let's write things with exponents. So we have log base 5, and square root of x is really to the 1/2, minus log, and this is a base 5, so I want to rewrite the 25 as 5 squared, minus log base 5 of y cubed. So in this first one, this 1/2 is going to come out in front, so we have 1/2 times log base 5 of x. In this second piece, this is a property. We have a base and a base that match, so we end up with just having a -2. And in this third piece, we're going to bring that 3 out in front, so we have 3 times log base 5 of y. And that's expanded. And again, we put a minus here and a minus here because both the 25 and the y cubed were in the denominator, which means they're both being divided by, so we have to subtract both of them. So this time we're going to go the other direction. We want to smash things back together. So this is going to be log. We're going to write 1 log. This addition means that that 25 and that 4 are going to get multiplied together. Remember, when we smash it back together, addition becomes multiplication. When we split it apart, multiplication becomes addition. So this becomes log of 100. And remember that if you don't see a base, there's really a 10 there. So we can rewrite this as log base 10, and 100 is really 10 squared. And that's a property, so we really just get an answer of 2. Here, this wants us to, again, smash them together. There's a subtraction sign, which means that when we smash them together, it becomes division. So we have log, and we'll put parentheses. The first thing goes on the top, and the second thing goes in the bottom. We can't simplify that at all, we just leave it. Again, this says write as a single logarithm, so we want to smash things together. But when we have numbers in front, we have to move them first. So that 2 is going to become an exponent, and that 1/2 is going to become an exponent. So we'll have log, or ln of x squared, plus ln of x plus 5 to the 1/2. And then because it's addition, we're going to smash these together. And when we smash them together, it becomes multiplication. So I'll write ln once, parentheses, then we'd have x squared times x plus 5 to the 1/2. And then the last thing is that we don't like to leave fractions as exponents. We can rewrite that. Remember that 1/2 exponent really means a square root So that is our final answer. So we'll do this again here. We're going to smash it together. We have an exponent of 2 there, so we're going to move that exponent back. So we get log of x minus 3 squared minus log of x. We have to do that first, just like when we're splitting things apart, that's the last piece we do. When we're smashing it together, it's the first thing we do. This is subtraction, so when we write it as 1 log, we're going to put parentheses. We'll put this first thing on top and the second thing on the bottom. Again, we'll do this. So we have a number in front. We're going to write that as an exponent. Number in front, we'll write that as an exponent. Number in front, we'll write that as an exponent. So if we do that, we get log of x to the 1/4 minus log of 5 squared minus log of y to the 10th. Let's deal with this x to the 1/4 first. Remember that really means a 4th root of x. And we could go ahead and say 5 squared is 25 and log y to the 10th. Okay, so now we're going to smash it into 1 log. So I'm going to write log once, and I'm going to put a parenthesis. The first thing goes on top. So we get 4th root of x over. This minus tells you that this piece, this 25, is going to go on the bottom. And this minus tells you that this piece, this y to the 10th, is also going to go on the bottom. The minus means that that's what we're dividing by. So if I make this a little more readable, we get 4th root of x over 25y to the 10th. And that's condensed. It's written as a single log. So the change of base property is the last thing in this section, and that allows us to be able to type something into our calculator that doesn't have a base of 10 or a base of e, because remember those are the only buttons we have on our calculator, is a base of 10, the log button, or a base of e, the ln button. So we can use either. We can write log, we can use our log button with m, the big number goes on top, and divided by log of b, the base, on the bottom. Or we could use our ln button, but it's still log of m, the big number on top, over the ln, the base on the bottom. This one that's already down low is what stays down low. It stays on the bottom. And here we probably should put parentheses around those numbers. So again, this allows us to use our calculators, and we'll see that in the next example, this last example. So here we're going to do it 2 different ways and see that it shows us the same thing. So first of all, we'll start with using the log button. We'll have log, and it's the big number on top, 2506. And then the 7 that's on the bottom stays on the bottom. And when we're typing things into our calculator, when we're rewriting it, we have log on the top and log on the bottom. Notice that when we're smashing things together, we only have a log written once. So in your calculator, you would just type in log 2506, close your parentheses, divided by log of 7, close your parentheses, equals 4.0, hundredth means 2 numbers, 2, and after the 2 is a 1, so it would just stay 4.02. The other way we can do this is with natural log. So we could have natural log of 2506 over the natural log of 7. So if we type this in using our LN button, then we should get exactly the same thing. So let's look at example B. We'll do it with a log button first. We'd have log, and we put the 140 on top, close the parenthesis, and then the log, remember the 5 is down low so it stays on the bottom. We use the log twice when we're typing it into our calculator. And we get 3.0. The 7 is followed by a 0, so it would stay a 7, 3.07. We could also use the natural log button, so ln 140 is on top, ln of 5 on the bottom. And if you type that in, make sure you close your parentheses before you hit the next log button. You should get exactly the same thing. So it's really important that in this section we get comfortable with using the different properties, the expanding and condensing, because in the next section when we solve, we're going to need to use those.